ケットになるなっていうのも見えてきているところもありますので、そこについてはその原因究明と対策とはちょっと別なラインで、少し改善を加えたこともあります。それからエンジニア自体が、この失敗から非常に多くのことを学ぶっていうのは、私もそうだったんですけれども、かなり強くなったと思ってます。ですから、2号機はその強くなったエンジニアで良くなったロケット、これでなんとか成功につなげたいなっていうふうに思ってます。
今後の展望ですが、
はい、
2号機打ち上げが成功してさまざまなデータが確認できて、これからどんな未来を作っていくことになりますか？
日本というのはすごくこの信頼性の高いロケットを作るっていうお家芸のようなことがありますので、まずその自分たちの目指すロケットを仕上げるというところはまず必要だと思ってます。その後でこのロケットを成長させていく、この世の中のニーズにフィットさせていくっていうことはもう今から並行して考え始めてますけれども、日本のロケットだからこれ打ち上げてほしいなっていうようなに思っていただけるようなロケットにしていく必要がありますし、それはロケット本体だけではなくて総合システムですね、システムオブシステムズ、種子島宇宙センターも含めてここから打ち上げたいなって、打ち上げてもらいたいなっていうふうに思っていただくにはどうしたらいいかっていうのを考えていく必要があると思ってます。このロケットの目標であります安心して使っていただけるロケット、そしてそれを世界中の方に使っていただけるロケット、ここが本当にこのロケットのコンセプト、大事なコンセプトなので、それを早く実現したいなというふうに思ってます。あちこちの展示物から引っ込みに出てきて、黄色のこの丸い下でグレーの子だけ赤抜けないようにする柱はそこに、上が2段のエンジンの部分が、もう動けないじゃないですか。開くんですね、スライド。
やっぱり大きいですね。いよいよ打ち上げですが、どのような思いですか
？1年かけてなんとかその気持ちを整えながら2号機にようやく集中できるような状況になってきましたので、もう一山登るという意味で再挑戦だと思ってます。一日も早くその H3 を皆さんに使っていただけるようにしたいと思ってます。頑張ってくれよっていう気持ちですね。
Hori-san, I was asking Mr. Okada about his enthusiasm towards the project in this video. Kotani-san, what did you think? Well, H3 project is one of the biggest projects in JAXA, and launch vehicle is a key to going to the outer space. So I'm sure he was under tremendous amount of pressure, and I was able to feel that working close to him, and he was trying to identify the cause, and he had to confront a lot of difficulties, but I think he had this pure thought of wanting to take H3 launch vehicle back to the central stage once again. So whether it be myself, other project managers, or everyone, I think we are all, trembling with excitement right now. It would be great to see Mr. Okada and all the project members full of smiles after the successful launch. Yes. So let's go back and take a look at the Launch Control Center LCC once again. Yes, everyone look quite relaxed. They are seated in their seats, and they are going through their confirmation work. If something is happening, then people tend to gather in those locations that they go to meeting rooms, but nothing like that right now. It seems everything progressing quite smoothly. We are also connected to this site. This is the Range Control Center, abbreviated to RCC. And what we saw before was LCC, and this is RCC, the Range Control Center. LCC is responsible for the sequence prior to the launch, but in the case of RCC, they have different role. So after the launch vehicle is launched, it's responsible for tracking the launch vehicle. And so the ground stations are on the ground with a large antenna, and they actually communicate with the launch vehicle to obtain information. That information goes to RCC and to understand the state of flight of the launch vehicle. So the monitoring is done here. And project manager, Mr. Okada, is also stationed at the RCC, right? Yes. You can see him just in front of the flag. So Mr. Okada, the project manager, and all of the key people of the launch is also seated here. If there is a person responsible for satellite, is also located here. Thank you. We are now approaching the time of the launch. So please allow us to introduce the flight plan for today.
種子島から打ち上げられる H3 ロケット試験機2号機。ここからはそのフライトシーケンスを紹介します。まずはおよそ1分56秒後、SRB3 を分離します。そして3分34秒。
So 3 minutes and 34 seconds afterwards, the fairing is separated. Then 5 seconds after 5 minutes, we will be separating first stage and second stage. And 5 minutes 17 seconds later, we'll start ignition of the second stage engine. Then after that, launch vehicle will continue on its flight, and about 16 minutes and 43 seconds later, CSAT-1E, a small satellite, will be separated, and TIRSAT will also be separated. And in the end, the payload for confirmation of the launch vehicle, Vehicle Evaluation Payload-4 will be separated. Then the second stage will fall into the Indian Ocean safely, and until the completion and ignition of the second stage and the CSAT-1 separation, this will all be covered in the live stream today. So what you saw was the image of the flight sequence. And so if you'd like to introduce the countdown sequence prior to the launch briefly. And so there are a number of points that I'd like for you to focus on. The countdown has already started, and 240 seconds prior to the launch, which is 6 minutes before the launch, we start the automatic countdown sequence, which is done on a program basis. And 18 seconds prior to the launch, we will switch to the flight mode. So flight mode is activated, all system preparation completed 15 seconds prior, and 6.3 seconds prior to the liftoff LE9 ignition. It takes a little time for stabilization. So and then the solid rocket booster will be ignited just before the launch for the liftoff. So if you could focus on these timings. So from here, we will switch to the screen to live feed from the launch site and audio to the remote control center. Here we go.
540打ち上げ9分前です。機体は最終的な確認作業が続けられており、現在のところすべて順調との報告を受けています。
It is 9 minutes to launch and counting. H3 is undergoing its final confirmatory reviews. Currently, everything is going smoothly and going well so far.
打ち上げ8分前より打ち上げに向けた秒読みが開始されます。
We will start the final countdown at T-8 minutes.
507、506、505、504、503、502、501、500。490。480。打ち上げ8分前です。現在各系ともロケット打ち上げの最終作業を行っています。また警戒区域の安全は確認されています。
It's 8 minutes to launch. All systems are now in their final operations. The restricted area has been vacated and cleared.
450、440、430、420、
安全系準備完了。
Range safety system is go.
車上系準備完了。
Range system is go.
408、407、406、405、404、403、402、401、400。390、380、370、360、
打ち上げ6分前です。現在車上の天候は晴れ、気温摂氏 14.4 度、北北西の風毎秒 1.9 メートルです。
It's 6 minutes to launch. The current weather at the launch site is fine. Temperature is 14.4 degrees Celsius. Wind is 1.9 meter per second from the northwest. The weather is still a go, and currently there is no constraint for launch.
本日の打ち上げ予定時刻は日本時間の午前9時22分55秒です。
Today's scheduled lift-off time 9:22:55 seconds a.m. Japan Standard Time.
310、309、308、307、306、305、304、303、302、301、300。
打ち上げ5分前です。
It's 5 minutes to launch.
95、94、93、92、91、290、89、88、87、86、85、84、83、82、81、280、79、78、77、76、75、74、73、72、71、270、69、68、67、66、65、64、63、62、61、260、59、58、57、56、55、54、53、52、51、250、49、48、47、46、45、44、43、42、41、240、39、38、37、
自動カウントダウンシーケンス開始。
Automatic countdown sequence has been initiated.
現在ロケットの管制は竹崎発射管制塔から行われています。
H3 is now operated under the command of Takesaki Launch Control Center.
19、18、17、16、15、14、13、12、11、210、209、208、207、206、
2段液体水素地上油圧開始。
Pressurization process of second stage liquid hydrogen has been initiated.
97、96、95、94、93、92、91、190、89、88、
1段液体水素地上油圧開始。
Pressurization process of first stage liquid hydrogen has been initiated.
打ち上げ3分前です。
3 minutes to launch.
75、74、73、72、
1段液体酸素地上油圧開始。
Pressurization process of first stage liquid oxygen has been initiated.
63、
機体の電源が外部から内部に切り替えられました。
The power has been switched to the internal systems.
54、53、52、51、52、53、54、55、56、57、58、59、60、61、62、63、64、65、66、67、68、69、70、71、72、73、74、75、76、77、78、79、80、81、82、83、84、85、86、87、88、89、90、91、92、93、94、95、96、97、98、99、100、101、102、103、104、105、106、107、108、109、110、111、112、113、114、115、116、117、118、119、120、121、122、123、124、125、126、127、128、129、130、131、132、133、134、135、136、137、138、139、140、141、142、143、144、145、146、147、148、149、150、151、152、153、154、155、156、157、158、159、160、161、162、163、164、165、166、167、168、169、170、171、172、173、174、175、176、177、178、179、180、181、182、183、184、185、186、187、188、1 150、49、48、47、46、45、44、43、42、41、140、39、38、37、36、35、34、33、32、31、130、29、28、27、26、25、24、23、22、21、120、19、18、17、16、15、14、13、12、11、110、109、108、107、106、105、104、103、102、101、100、99、98、97、
2段液体酸素地上油圧開始。
Pressurization process of second stage liquid oxygen has been initiated.
88、87、86、85、84、83、82、81、80、79、78、77、76、75、74、73、72、71、70、69、68、67、66、65、64、63、62、61、60、
打ち上げ1分前です。
1 minute to launch.
56、55、54、53、52、51、50。
フレームデフレクター冷却開始。
Flame deflector cooling is initiated.
44、43、42、41、40、39、38、37、36、35、34、33、32、
ウォーターカーテン散水開始。
Water spray system at the launch pad is activated.
25、24、23、22、21、20、19、18、17、16、15、
フライトモードオン。
13、
Flight mode on.
11、10、
加工品トーチ点火。
Hydrogen purge igniter on.
全システム発射完了。
All systems are go for launch.
メインエンジンスタート。
Main engine starts.
SRB3 点火リフトオフ。
Solid booster ignition and lift off.
H3 ロケット試験機2号機は2024年2月17日午前9時22分55秒に種子島宇宙センターから打ち上げられました。
We have a successful lift-off of H3 launch vehicle test flight number 2 from JAXA Tanegashima Space Center at 9:22:55 seconds a.m. on February 11, 2024, Japan Standard Time.
打ち上げ以降ロケットの管制は竹崎発射管制塔から竹崎総合司令塔に引き継がれています。
The operation control of H3 has been switched from launch control center to range control center.
ロケットは現在東南東方向の太平洋上へ飛行しています。
H3 is now flying above Pacific Ocean to the east southeast.
打ち上げ後1分が経過しました。
It's 1 minute into flight.
66、67、68、69、70、71、72、73、74、75、76、77、78。
ロケットは正常に飛行中。地上局のロケット追尾状況も正常です。
The H3 flight is on course and the ground stations are tracking the launch vehicle and all is good.
91、92、93、94、95、96、97、98、99、100、101、102、103、104、105、106、107、108、109、110、11、12、13、14、15、16、17、18、19、120、
SRB3 分離。
Solid booster separation.
ロケットは現在種子島内之浦の地上局から追尾されています。
Currently, Tanegashima and Uchinoura ground stations are tracking H3.
37、38、39、140、41、42、43、44、45、46、47、48、
第1段エンジンの燃焼は正常、制御系、飛行経路も正常です。
The combustion of the first stage engine, attitude control, and trajectory are all nominal.
ロケットは順調に飛行を続けています。
The H3 flight is on course.
77、78、79、180、81、82、83、84、85、86、87、88、89、190、91、92、93、94、95、96、97、98、99、200。
衛星フェアリング分離。
So the satellite fairing has been separated. Now we have been able to confirm that. And so H3 launch vehicle test flight number 2 has been launched. It's going quite steadily so far. And so the screen that you're able to see right now, and this is called the flight status indicator for public for the H3 launch vehicle, which is abbreviated to H3 FIP. And as you can see right now, the direction the launch vehicle is traveling on is shown in this line. And so we receive information from the launch vehicle and is reflected into the screen. So the information from the launch vehicle on a real-time basis is reflected into the screen. And you can see the numbers changing on top left. On top left, where you can see 10,000, this is showing the velocity, and it's velocity in terms of speed per hour, so it's quite significant, but it's about 8 kilometers per second. That is the acceleration too. And next to that is an elevation of the height, and the time is shown in the middle. And so the ignition of the first stage engine is about to be completed soon.
So the first stage engine, the separation has been successful. The initial second stage engine has been completed. So when the event occurs, you would be able to see the dots, and the event had been confirmed. So it's going steadily. So there would be some time until the initial second stage engine cutoff, 16 minutes 30 seconds. So we still have some time until the next event. So the main mission is the second stage orbit injection, meaning the initial second stage engine cutoff. When it's completed and when the data is acquired, the objective for this flight has been completed. So that is true. So as a launch vehicle, we would have been able to validate that. And using this opportunity, 2 piggyback microsatellites are being mounted. So the separation of these satellites is also another important mission. So after that, the CESat-1E will be separated as well. So we would like to monitor that closely. So we would like to explain to you how to look at the FIP. Kotani-san, please. So from Tanegashima Space Center, we are looking at the flight, and in the black dot, you would be able to see the events. And there will be various events, and you would not be able to see that because it's far out. When the event is close closer, you would be able to visually check it. On the upper left, you would be able to see the speed at 12,600, and it would get to 28,000, meaning that 8 kilometers per second. Altitude is 560 kilometers, so it's even higher than ISS already. And it's 7 minutes 46 seconds after the launch. So that's how you look at the FIP. So up to this point, there has been no issue. That's correct. So you see the flight route in the line. And the announcement says that it's normal and it is on the right path. So the second stage engine is working very hard right now. So last time we were not able to get there, so it's working very hard this time.
Velocity is about 3.6 kilometers per second.
So you would be able to see this soon, but on the upper left, VEP4 separation event will be shown soon, and this will go around the Earth before the separation. So I don't think that we would be able to confirm the separation during this live streaming, but there would be press conferences and also announcement on the announcement on the website about what happened to VEP4. So please look at that as well. So TIRSAT, another microsatellite. After a CE-SAT separation, about after 9 minutes, it would be separated above Australia, and we would not be able to acquire the separation signal immediately. So please check the press conference whether it was a success. So the initial second stage engine cutoff is X plus 15 minutes, so that will be about 7 minutes from now. We still have some time, so let's talk about H3.
Yes, there was an announcement, and the combustion of the second stage engine is going without a problem, and 690 kilometers above the sky right now.
Of the second stage engine, attitude control and trajectory are all nominal. The H3 flight is on course. Current altitude is about 690 kilometers. Velocity is about 4 kilometers per second.
And so there is a periodical announcement which is reassuring, and the announcement is such that everything's going well in terms of velocity and also attitude. Everything is looking quite normal right now. And let's talk about H3 a little bit. It's a great opportunity. And H2A is a launch vehicle that is highly reliable, and that is what we are operating right now. But why are we developing a new launch vehicle, H3? Why was it necessary to develop H3? Can you explain? Yes, H2A was developed quite a long time ago. And it is still very active right now, which is great. But the satellite loaded is becoming more diverse. So we have the satellite of various shapes now. And also, the market for the launch is becoming more intense. And so there is a price competition. And so the launch price has been coming down significantly. And so H3, a launch vehicle in that regard, is able to launch more in comparison to H2A. And so not just the Japanese satellite, but also obtain a satellite abroad as well. And so we need to also achieve the objective of lowering cost. And so from H2A, we have reviewed all the system. We are going to succeed the technology, but the price will be lowered to about half that of H2A. So these were the challenges we have been working on. And H2A has a core in the middle, and they have the solid rocket booster adjacent to that. But H3 can be launched just based on the core, and that is one of the key points. And so in that regard, we are able to launch the vehicle quite inexpensively, and we are able to launch just based on core. But you're able to also utilize the solid rocket booster. You can use this, you can increase it to 2 or 4, and you're also able to change the design for the LE9 engine as well from 1 to 3, and so it's quite unique. So irrespective of the weight of the satellite, we are able to change the format to match that. That is one of the unique features. And we are looking at the telemetry, and at this point in time, the flight seems to be going quite well. Yes, the speed continues to increase. It has maintained altitude, so I think it's going quite well. And in about 2 minutes' time, the second stage engine, the engine cutoff will occur. So CSAT-1E separation is upcoming. That's going to be fun. And immediately after the second stage engine cutoff, we are scheduling to separate this satellite. CSAT-1A, 1E has Mount Fuji developed by JAXA. I think you've explained that. And we are able to accurately measure the distance from the Earth to the satellite using this device. Why do we need something like this? Well, I can talk for more than an hour on that topic, so let me be brief. Around the Earth, there are space debris, and there are also active satellites as well, but there are a lot of objects, and we are monitoring everything right now, and there are about 25,000 the objects flying above the Earth in the space, which are all monitored, and you use the telescope from the ground, and confirming when they fly by. We'll put that into simulation, and we actually track how they travel. But accurate location, when you are able to understand the accurate location, then you can, so whether those objects, we need to monitor, make sure that they don't collide with some ISS and so forth. Event is upcoming soon.
So there will be the initial second stage engine cutoff coming soon. So if this is completed, then the second stage, the orbit injection would have been successful. So
altitude is about 694 kilometers. Velocity is about 6.4 kilometers per second.
もうすぐですね。
almost there. The initial second stage engine cutoff had been confirmed, and the CSAT-1E will be separated soon. CSAT-1E has been successfully separated. So this will be the first satellite put into the second stage orbit. So it's so moving.
We will now conclude our live coverage of the H3 test flight number 2. Thank you.
So once again, the initial second stage engine cutoff was conducted successfully. So the mission was complete for second stage orbit injection. CESat-1E was successfully separated. So I was so moved. And at the same time, so the evaluation has been made for the vehicle, and I feel that there are so many things that would be coming up to us, and the story of H3 will begin from today. So I hope to have the support from all of you to H3. So H3 I will be standing on a new starting point. But the people who were involved in H3 launch vehicle and people who have supported this project, and I feel so happy that this became a successful launch. So there were so many encouraging messages, and I felt that there were so many people who were cheering for H3. And H3 it would become a launch vehicle which would be launched frequently, and I hope to have further support from everyone. So TIRSAT and VEP4 separation, as well as the second stage re-entry, the result of that will be brought to you by a press conference, and that would be live streamed on JAXA channel. And as for the details of the press conference, you would be able to look at the website of JAXA as well as social media of official social media of JAXA. So I hope that H3 will have continued support. So Okada-san was on the images, and I was very happy to see him happy. The mission still remains, so TIRSAT separation and VEP4 separation, and it would re-enter. So we need to wait and see what will happen. But there would be third and fourth launches, so I hope that everyone will follow us closely. So H3 will be carrying various satellites from around the world, and at JAXA there are many projects going on, so please support those projects as well. So Epsilon S launch vehicle, which is a new type of launch vehicle, we would like to launch that soon, so please look forward to that. So H3, the second H3 launch vehicle live streaming. Thank you for watching. Thank you for watching us.